So we have seen the history of discovery of an atom. The present accepted structure of the atom is compared to a solar system. Like the planets revolve around the sun in fixed orbits. Similarly, this is the present accepted structure of the atom. So there is a nucleus in the center, and the electrons revolve around the nucleus in fixed orbits. So the present structure of the atom is compared to a solar system. So let's see the structure of atom again. So this is the atom. The central part of the atom consists of the nucleus. The nucleus is made up of neutrons and protons, and the atom has a nucleus in the center, and the electrons revolve around the nucleus in the fixed shells, which are also known as orbits. So these are the three subatomic particles of the atom. So let's look at the first one, protons. The charge of each proton is plus 1.602 into 10 to the power minus 19 coulombs. The charge of electron is minus 1.602 into 10 to the power minus 19 coulombs. And neutrons, we know, are neutral, so they have no charge. So if you will see, these are big, complicated values. So to avoid this complication, in chemistry, we make use of a simpler technique. We take relative charges. So the charge of proton is taken to be plus 1. So relatively, we get the charge of electron to be minus 1. And neutrons are neutral, so the charge of neutron is 0. So you see that the charge of proton and electron, they are equal, but they are opposite in signs because they are oppositely charged. So in an atom, the charge of proton and electron is equal. An atom is always electrically neutral. So if we have, say, let N P be the number of protons in the atom into Cp. This is the charge on each proton. So this is the total positive charge in the atom. Since an atom is electrically neutral, so the total negative charge. So let Ne be the number of electrons in the atom into Ce. This is the charge on each electron. So this is the total negative charge in the atom. So now we know that the charge of proton is equal to the charge of electron. So if an atom is electrically neutral, the number of protons in the atom is always equal to the number of electrons. And this is vice versa. Since the number of electrons are equal to the number of protons, so the atom is always electrically neutral. So let's look at an atom here. The protons are depicted by the red circles with a positive sign in them. So let's count the number of protons. We have 1, 2, 3, 4 protons, and the electrons revolve around the nucleus. So let's count the electrons. 1, 2, 3, 4. So in this atom, we have 4 protons and 4 electrons. This means that the atom is electrically neutral. That is, the number of electrons is equal to the number of protons. Why don't the electrons which are revolving around the nucleus, they fly away from the nucleus? Why don't they fly away? We know that the electrons are negatively charged and the protons are positively charged. Also, in physics, you must have studied that unlike charges attract. So there is this force of attraction between the protons and electrons, which pulls the electrons towards the nucleus. And because of this force, the electrons do not fly away from the nucleus and they revolve around the nucleus in the fixed orbits. So here we have, Dr. Gary was observing an atom. He noticed that 4 electrons were revolving along a path. What is the number of protons present in the atom? So we know that an atom is always electrically neutral. So the number of protons is always equal to the number of electrons in the atom. Since we have 4 electrons in the atom, so the number of protons present in the atom is also equal to 4. So since there are 4 electrons present in the atom, to maintain the electrical neutrality of the atom, number of protons in the atom is also equal to 4. What is the total charge of the atom that was observed by Dr. Gary? So we know that an atom is always electrically neutral. So it's not dependent on the number of protons and electrons which are present. The charge, the total charge on an atom is always 0, because an atom is always electrically neutral. So the number of electrons is always equal to the number of protons, and that is why the total charge on the atom is always 0. Let's look at the masses of these 3 subatomic particles now. So the mass of proton is 1.67 into 10 to the power minus 27 kg. Mass of neutron is 1.67 into 10 to the power minus 27 kg. And mass of electron is 9.1 into 10 to the power minus 31 kg. Again, these are big, complicated numbers. So to avoid this complication, we use the relative masses of these 3 subatomic particles. The relative mass is taken with respect to the mass of proton. So the mass of proton is taken to be 1 AMU, where AMU stands for atomic mass unit. So with respect to the mass of proton, the mass of neutron also becomes 1 atomic mass unit, because the mass of proton is equal to the mass of neutron. Therefore, the mass of neutron is also 1 atomic mass unit. The mass of electron is much less as compared to the mass of proton. So with respect to the mass of proton, the mass of electron comes out to be 1 by 1840. That is 1 upon 1840 atomic mass unit. So this value shows that the mass of electron is much less as compared to the mass of proton or the mass of neutron. So now, if you are wondering what the size of atom and the nucleus present in the atom is, let's take this entire football ground equal to the size of atom. So the nucleus is just a small stone or a small pebble which is present in this football ground. So the nucleus is this small as compared to the entire atom. So let's recall the charge of the 3 subatomic particles. So the relative charge of proton is taken to be plus 1. With respect to the charge of proton, we get the charge of electron to be minus 1, and neutrons are neutral. Therefore, the charge of neutrons is 0. Now the masses of these 3 subatomic particles. So the mass of proton is taken to be 1 atomic mass unit. So with respect to the mass of proton, we get the mass of neutron also equal to 1 atomic mass unit, and the mass of electron is 1 upon 1840 atomic mass unit, which is much less as compared to the mass of proton or the mass of neutron. So these are the characteristics of the 3 subatomic particles of atom, that is the protons, neutrons and electrons.